Welcome back to the lecture. Let's look at structuring our Python code. So functions is the basic way to restructure our code and avoid writing code again and again. So we define a function with this def command on the left, and this is the name of the function, and here are the arguments of our function. Because we are organized, we give a small comment, in this case, to say what is the return, what does the function do. And for functions that return values, we use this return command. So in this case, I'm just adding the parameters a plus b. So if I print my sum, my function, with parameters 1 and 2, it will just add them. So since we had this comment just under the function, if we use help my sum, we have the comment that we wrote on the function, return a plus b. And help can be used with any function that you encounter in the tutorials. Now, some of these arguments, they can have names. So here I'm calling argument A with value 1, argument B with value 2. I could have as well just called my sum 1 plus 2, but I call them with the name that was in the definition. And so this enables us to do the following. We can have arguments that have to be defined. So you need to call the function with this argument. It's a mandatory argument. But other arguments, you can give some default values. So here, A is a mandatory argument. We have to provide it for our function. And B, if we don't provide any value for the second position, or by explicitly writing B equals 2, then the function will assign the value to my argument B. And so you see here my sum called Richard1, which is the first argument A, gives value 3, because it's assuming that value B, the second value of my sum, is implicitly has value of 2 if it's not specified. Now recall in the first lecture we talked about none type, about absence of value, and you can use it in the definition of functions. So here I say that my second value, B, it's initiated with a value of none. And so I can test inside if this was the value, if no value was provided for B, then I can assign it myself. So this example is a bit redundant because I could have said it here, B equals to 2. But keep in mind, when you start writing functions that already have some complexity, this is really interesting to be able to specify the values of your arguments inside the function, and not necessarily at the level of the definition of the function. So you see, it gives exactly the same result, but this is a very powerful mechanism that you may use as well. Functions can also have multiple return values. So in this case, I define the function, which has two arguments, A and B, and I return A plus B on the first return value and the product of A and B on the second one. To recover these values, this is the syntax. You place two variables separated by a comma, and you assign the outcome, the return values of the function, to these two variables. Now if I print them, my sum will have the sum of 2 plus 3, and my product will have the product of 2 times 3. And this is another way to provide that output. Let's say I want it to be a bit more specific and print that 5 would be my sum and 6 would be my product. So I use this f-strings notation where I place my variables between the curly braces, as we saw in the previous lecture. Now functions don't always need to have return. So here I have a function that takes two arguments and does something, there's a product of the arguments, assigns it to variable c, but there is no return value. So in this case, when you call that function, the return value is none. There is always a return value, but if you did not define the return value is of none type. It's a none. Okay, so we're back to coding time. Let's go to exercise 6 and use functions to better structure our code.